Awesome. Welcome everyone to our session today at Microsoft Ignite. We're going to be talking to you about how you can build, modernize, and secure your AKS workloads with Azure Linux. My name is Sudhanva Huruli. I'm a PM on the Azure Linux team. And alongside with me, I have Dongha Paek, who's going to come on and talk about the benefits of Azure Linux later. We have a fairly packed agenda today, so we're going to start with an intro to Azure Linux, what it is, the history, why Microsoft created it. I'll show a demo of how you can get started. Then Dongha's going to walk through the benefits, innovations. We have two really exciting security announcements today. And then we'll wrap things up with roadmap, resources, and Q&A. So before I start, I want to just see a quick show of hands. How many folks here before this session had heard about Azure Linux? OK, that's a lot. Bit of a trick question. How many folks have heard about CVL Mariner? OK, a lot lower. The reason I ask those questions is I want to talk a bit about the history of Linux at Microsoft and focus on really 3 dates and timelines. 2012 to 2014 is when Microsoft actually announced endorsed distros. So CentOS, Ubuntu were the first. And then fast forward to 2016-19, these distros were making up over 50% of our Azure workloads. Today, that number is actually closer to 70%. In 2020, we quietly released a project on GitHub called CVL-Mariner. In 2023, we actually rebranded this project and released it as Azure Linux. So for those, the 2 people that put their hand up, they knew that CVL Mariner was the internal code name that we released a long time ago on GitHub. In 2020, Microsoft looked at our internal Linux fleet, and there was a ton of services that were running Linux distributions. The challenge with this is when there's a CVE, you're not sure which services and distros are actually affected. Anytime you need to patch the fleet super quick, when you have a disparate set of services running Linux distributions, it becomes challenging. Likewise, performance and quality become challenging to manage. How do you ensure that you can centralize performance teams to optimize the Linux distro? How do you ensure that you can maintain rich quality of the Linux distribution for a variety of environments? And lastly, and perhaps the biggest challenge Microsoft faced was compliance. You had multiple teams trying to reach FedRAMP, FIPS, CIS level compliance. So in 2020, we released CVL Mariner, and we went on this journey internally at Microsoft to standardize on a Linux distribution. Fast forward to today. Over 80% of Microsoft services that run Linux are running Azure Linux. This is across Xbox. This is across Office. This is core Azure services, Azure Edge services, and even bare metal services such as LinkedIn. How many people here use Cloud Shell? Cloud Shell, if you use the Bash Linux version, is running Azure Linux underneath the hood. So I want to talk about what Azure Linux is. And when it comes to talking about Linux distros, I like to talk about 3 things. The kernel, at its core. Azure Linux uses the upstream LTS Linux kernel. This kernel is optimized for the Azure environments, whether that's on edge or local environments. We harden it with secure defaults, and we ensure we support x86 and ARM64. In other words, all the silicon architectures on Azure. We also take the time to ensure we support the latest SKUs in Azure. This is CVM SKUs, memory optimized, GPU SKUs. Azure Linux is in the critical path to enable all of these SKUs. Second is Azure Linux Core. These are the user space packages that you'll interact with most. Azure Linux follows the RPM format. So those coming from other enterprise Linux distros, or Fedora or CentOS, will feel very familiar and at home with Azure Linux. On packages.microsoft.com, we publish over 15,000 packages, actually. And our goal is to have a super small footprint with Azure Linux. So we start with a small base image, and then teams like AKS pick this up and add their cloud-native binaries to offer it for AKS customers. And lastly, around-the-clock protection. The core value proposition of Azure Linux is the fact that we build all of our packages on secure build servers within Microsoft. This ensures supply chain security. In addition, we have a strong and vast security team that is constantly monitoring for CVEs. These are common vulnerabilities and exposures that packages or binaries may have. We have an SLA of 5 days for critical CVEs, and we strive to patch high CVEs within 30 days. Beyond these, Azure Linux has a monthly release cadence. So we release the distro on a monthly cadence, and that release will contain bug fixes and low, medium CVE patches. So how do you as customers consume Azure Linux? That's going to be via AKS today. For AKS, Azure Linux offers a lightweight operating system where packages are carefully selected for AKS. It's available where you need it on edge and cloud environments. And lastly, Azure Linux is the vehicle for security innovations within AKS, as Dongha will talk about. So anytime we think about sandboxing innovations or immutable hosts for our internal needs, Azure Linux is the Linux distro where those innovations happen, and that's where we're also releasing that to public customers today. Since we announced Azure Linux 2 years ago, we've seen adoption by over thousands of customers across many industries and verticals. Customers have talked about strong reliability because of the tight integration with AKS that we offer. What I mean by that is when we update an Azure Linux package, we are ensuring and testing it on AKS before releasing it. If there's a regression outage, we halt the entire distro release. Customers have also talked about performance benefits. Because we get to optimize for AKS, this means that the Azure Linux distro for AKS is much smaller. So all sorts of operations, from VHD creations to actual node creations, scale-up time, delete time, all of these are faster. And I want to introduce Carlos from 𝗲𝗲. And I think, as folks may know from Ignite, 𝗲𝗲 is the new Contoso. And Carlos is the CTO of this company called 𝗲𝗲, and he has heard this presentation from me, and he has decided to optimize his fleet by moving to Azure Linux for security and reliability reasons. He has two prime concerns. He's worried about his existing applications needing to be changed because Microsoft's Linux distro may be different than the Linux distros people are used to today. He's also worried about needing additional capacity. So he has an existing cluster that's working, albeit with a few challenges, and he's worried he needs to create new node pools, and he doesn't have the luxury to do that. So let's go ahead and take a look at how we help Carlos and 𝗲𝗲. The application that Carlos is using is a simple pet store application. It's a polyglot application that's running Vue.js storefront, Rust backend, RabbitMQ. In other words, it is an application which contains a various set of Linux containers. It's pre-built. Carlos has an existing cluster that's already up and running. Let's go ahead and do kubectl get nodes. You'll see that this is running a 3-node Ubuntu cluster. Let's verify that his pods are up and running as well. So we'll do kubectl get pods, and then let's check the service. So verify that endpoint is actually reachable, and you'll see that his pet store app is up and running. Now, to move these applications to Azure Linux, we've made it super easy. We've created a command called AKS update that underneath the hood upgrades the OS in place from one Linux distro to the other. You can use this not only to move from Ubuntu to Azure Linux, but you can also use it for the reverse. You can go from Azure Linux to Ubuntu if you please as well. This ensures that Carlos doesn't need to provision additional capacity just to move to Azure Linux. Once this command is complete, we can ensure that his other first concern, which is do his apps continue to run on Azure Linux, are also met. So once this command is done, let's go ahead and do kubectl get nodes again, and let's verify that we're in fact running Azure Linux. We're running Azure Linux 3.0, which is running the latest 6.6 kernel. Let's do kubectl get pods and see that all the pods are up and running. And then finally, let's do kubectl get service and check the endpoint again to make sure that the application's up and running. And it is. So in this brief demo, what you saw was an existing app that Carlos had built with a variety set of Linux containers, not necessarily Azure Linux, migrate seamlessly to Azure Linux without any additional capacity in place. But that's not all. Carlos is using Kubernetes because it has a rich ecosystem. And one of his other prime concerns is, what about all the monitoring and networking solutions I use? Well, Azure Linux strives to work with our partners in ensuring that they support Azure Linux. And this is bidirectional. What this means is anytime we have a new version of Azure Linux, partners that we support are getting tested on our servers, and we're working with partners to ensure that they are testing against Azure Linux before they release new versions as well. In addition to external partners, we tightly work with all of our first-party offerings. So that's Azure Container Storage, that's Azure Monitor for observability, and Defender for your security purposes. The final thing I want to touch on is open source and the community. So we consume plenty of binaries projects from the open source community, and we also contribute back to these projects. These are a few of the projects that we work very closely with in the recent past. The Linux kernel is probably the largest one that we have contributors to. There are various patches that we offer because we stick to the 5.15 kernel for 2.0 we did for 3 years. We're looking to do the same with 3.0 and the latest kernel there. So we're upstreaming a lot of backports and patches to the Linux kernel. And when Dongha comes up here and talks about some of our sandboxing capabilities, we're doing that in tight collaboration with the Kata and the containerd projects. The fact that we also use systemd means we're contributing back to the systemd project as well. So in this first section, I briefly talked about the history of Azure Linux, why Microsoft created it, what it is. It's an RPM-based Linux distribution that uses the upstream LTS Linux kernel at its core, some of our value propositions at a high level, and we saw some of the concerns that people like Carlos may have at Zava and how we help meet those needs. Now, I want to invite Dongha up here on stage to talk about some of the benefits and innovations we're making within Azure Linux and highlight some of the product announcements that we have.
Thank you so much, Sudhanva. Hey, folks. So today, I wanted to talk a bit more about the benefits and innovations within the Azure Linux. So what kind of benefits does Azure Linux offer compared to the other distributions available on Azure? Thanks to our strong integration with the rest of the platform, we are able to shift resiliency by testing earlier on in the pipeline. We are also able to offer an enhanced supply chain security by making sure all of the packages are signed with the Microsoft keys. We are also providing an improved performance, as mentioned by Sudhanva, by providing a lightweight virtual machine images for your Node OS. The first aspect I want to talk a bit more about is the resiliency. Oftentimes, customers running and deploying a large-scale infrastructure on Azure are often concerned that the OS upgrades might lead to frequent reboots, downtimes, and in some situations, even regressions. So how does Azure Linux protect against these type of scenarios? So in terms of the Azure Linux validation pipeline, what we do here is that in addition to a standard set of validation that we do for a general purpose Linux, on top of that, we are also running AKS-specific end-to-end testing for all of the packages, and then this is used as a gating factor in the release process. This means that whenever the customers actually get the release, it has been well tested for even on the AKS scenarios. In addition to that, I also want to highlight here that all of our main packages, such as the kernel, systemd, runc, and then containerd, are all stayed on a stable LTS branch, which means that if the customers have a specific dependency on a certain configuration, they're able to do so without being concerned about the regression. In terms of the performance aspect of Azure Linux, what we do here to ensure that there are limited amount of regression is in addition to a set of quality checks that we do, as shown in the previous slide, we do an extensive set of performance tests so that the metrics from a performance is used to also gate the releases. This way, whenever the customers actually get our monthly releases, we know for sure that it has been well tested. In addition to this, Azure Linux is very lightweight, also adding the benefit of faster pod startup times, faster operations, so the customers can scale their service depending on the loads that they're facing. The key takeaway from this particular side here is that in terms of a cluster creation time and then a cluster upgrade time, the customers are seeing either on par or improved performance in terms of compared to the other distributions available on Azure. You can also see that a month-over-month data, there are a lot less variance for Azure Linux. This means that whenever we do a monthly release, customers know exactly what to expect for when it comes to a creation and upgrade. And a lot of the benefits I just talked about is really truly due to the fact that Azure Linux is lightweight. Thanks to our strong integration with the AKS, we are able to prune out all of the unnecessary packages, such as text editors, GUIs, and other drivers that may be included in a more general purpose Linux image. We have around 520 packages, which is like 200 less for a Node OS. And then this reduced number of packages leads to a reduced attack surface, which also has the added benefit of having a easier CV maintenance. Talking about the CVs, in order for us to have an improvement on a CV experience for our customers, we offer a very strict SLA of 5 days for critical CVs. And as mentioned previously, fewer packages mean that we generally have fewer CVs to deal with in the first place. In terms of a secure supply chain, what we do here is that all of the packages are signed and validated using a Microsoft keys. And then in addition to that, we are building all of the binaries from a source on a Microsoft server so the customers know exactly where the codes are coming from. So in addition to these benefits that come from a baseline Azure Linux image, I also have two of the new addition to Azure Linux. The first one being a pod sandboxing on AKS feature, and then the second one being the OS guard that Sudhanva will talk about later. So going back to our customer Zava's journey in migrating and modernizing on Azure Linux, their Chief Information Security Officer, 𝗬𝗲𝗀𝗀𝗀𝗀, is looking to find improvements in some of the challenges that they're facing. The first one being a security assurance. How do you make sure that there is the isolation to protect container escapes and lateral attacks? How do you deal with the compliance, operational simplicity, and then how do you have improved agility? So how can Azure Linux help in these type of scenarios? Pod sandboxing on AKS is the latest feature that we are introducing, where we are providing a VM-level isolation for all of the pods running on your container. This means that you are able to mix and match trusted and untrusted workloads on a same shared environment without having to worry about them impacting one another. Let's dive into a quick demonstration to show you the sneak peek of how pod sandboxing works on AKS. The first thing I want to show here is that from a cluster standpoint, in addition to a run-C-based runtime, you can also have the option of selecting a Kata-based runtime called Kata VM isolation. The second one I want to point out here is that you are able to mix and match normal containers with a sandbox containers on an identical Azure Linux node. The next one I want to show here is the kernel isolation aspect. You can see that the host kernel and the normal container share a exact same kernel, whereas the Kata container has its own running on top of a cloud hypervisor. The first experiment I want to do here is the VM isolation demonstration through a container dsocket access. Especially in some of the more legacy work streams, you might see customers having a container that is trying to access host resources such as device nodes, container dsockets, and these are the very dangerous operations that we're trying to protect against. So if you are trying to access a container dsocket from a normal container, you can actually do so on AKS, and then you will be able to manipulate all of these containers running in that identical node. If you try to do the same experiment on a Kata container, you can see that the operational blocked. And then this is really due to the fact that for a file transfer between the node and the sandbox pods, we are using a virt.io file system, which specifically restricts the file shares to a normal files only and nothing else. The second experiment I want to do here is the kernel isolation demonstration through a forced kernel panic. If you try to force a kernel panic on a Kata container, you should be able to see that although the kernel is no longer responsive, the rest of the nodes remain in a healthy state. And then this is due to the micro VM layer that we have talked about that is containing the Kata containers. If you try to do it on a normal container, the expected behavior here is a bit different because the normal containers are sharing the kernel with the host. I am just echoing hello just to make sure that the kernel is indeed responsive. Then we're going to do a same set of commands. And then we should be able to see that the kernel is no longer responsive. There you go. And then now let's switch the tab, and then if we give it maybe like 10 or 15 seconds or so, you should be able to see that the node pool status here, so the second column, should turn from a ready to a not ready state for a Kata pool, which is hosting our normal containers and then the sandbox containers. And I have to speed up for the sake of the time, but as you can see here, this is indeed the expected behavior. So let's now dive a little bit deeper into what's happening under the hood for the pod sandboxing. So for your applications, hostile application or untrusted codes, they are contained within that micro VM boundaries, which means that they come in their own kernel space and user space. The benefit of doing this is that the customers are able to run a mixed set of workloads, such as AI agents, customer-facing applications, and compliance workloads, all on a same environment without having to worry about faulty container, maybe messing up something else on the node. And then this is really a way for us to combine the agility that comes from a Kubernetes environment to a security benefit that's come from a fully virtualized environment. If we take a deeper look into how the Kata container architecture works on AKS, you can see that we have Kata, shim, and then the containerd serving as a runtime for your container workloads. And below that, you have Cloud Hypervisor as your virtual machine monitor. At the top of the stack, you have Azure Linux-based Markup VM hosting the Kata agent. And then you can also find Azure Linux at the bottom of the stack as a node OS, providing a secure foundation for your workloads. This is really a way for our customers to run sensitive workloads all together, thanks to a strong isolation built into the platform without having to operational burden of trying to maintain multiple clusters. I'm going to now hand it back to Sudhanva so we can talk about the OS Guard and rest of our roadmap.
Thanks, Dongha. So I wanted to reintroduce 𝗲𝗲 and this time talk about Sarah, who's a platform engineer, and talk about what she's tasked with doing. Sarah's tasked with building a new platform for 𝗲𝗲 based on the learnings from what Carlos had. Some of the things that she's looking to run on this platform are going to be sensitive line of business apps, and as a result, she is interested in a platform that offers integrity enforcement from the start, so ensuring that the runtime components are actually what she intended to run. She also has some strong learnings about meeting compliance bars, so starting with a secure and compliant foundation from the get-go is better than trying to retrofit it later. And third, operational simplicity. What this means is in the original platform that Carlos had built, one of the challenges 𝗲𝗲 faced was the platform they provisioned wasn't the platform that they had 3 years down the line. In other words, line of business app teams that are running on Kubernetes clusters may change the file system, may introduce and install new binaries, and this changes the posture of the entire infra. And lastly, she's looking for a solution that offers defense in depth. So let's go ahead and take a look at how this new OS SKU that we have released in public preview today on AKS, called Azure Linux with OS Guard, helps Sarah and is the right solution for her. To start with, in your Bicep, ARM, or Terraform templates, you're going to use Azure Linux OS Guard as the new OS SKU. You'll notice that FIPS and Secure Boot are enabled by default on this configuration. In this example, I already have a cluster that is provisioned. So let's go ahead and do a kubectl get nodes once again. And what you will see is this is actually just running Azure Linux underneath the hood. That's because OS Guard is just Azure Linux with a few more opinions to make it more secure. It's running Azure Linux 3.0 with the same 6.6 kernel that we saw before. To show how it meets some of Sarah's problems, what we're going to do is deploy a debug container onto this node. And let's go ahead and try to mess with the node and see what happens. On Azure Linux with OS Guard, /user, which is where the Unix system resources live, is mounted as an immutable file system backed by dm-verity. So if you try to write to it, it is going to be a read-only file system. What this means for Sarah is that operational drift that she's worried about is not going to be a problem on Azure Linux with OS Guard. Let's go ahead and run bootctl. When you run bootctl, you're going to see that Secure Boot is on by default, and it's backed by VTPM. But that's not all. We're also using measured UKI in OS Guard. What measured UKI does is it packages up the kernel and the init ramfs in one package that gets signed. This ensures that more of the core init resources have their integrity checked at boot time. In addition to these, we are also offering SELinux on OS Guard. In preview, SELinux is going to be running in audit mode. So when you do a journal control on the AVC logs, Sarah's going to see all of the containers that would otherwise be denied if this were running in enforcing mode. This will give her a chance to tag and label her pods appropriately. We've also introduced IPE, which is integrity policy enforcement that ensures that only trusted code, both containers and the code within containers, are signed at runtime. Again, in audit mode during preview so that Sarah can collect valuable information. So what exactly is Azure Linux with OS Guard? It is a new OS SKU. It is secured end-to-end. So in addition to having Secure Boot on for runtime components, your user space components, including the file system /user and your apps, have their integrity checked at runtime. Because it's built on the secure foundation of Azure Linux, you're going to get things like FIPS, FedRAMP, secure supply chain, and all of the security value propositions of the CVE SLA that we talked about. The image for Azure Linux with OS Guard is serviced the same way as Azure Linux. It's on a monthly cadence. It's built on a minimal OS of Azure Linux, so it contains actually 100 fewer packages than Azure Linux does. And it inherits the CIS benchmarks that Azure Linux just recently announced. So because you have two options, I want to talk a little bit about when you would use which. Azure Linux for AKS is a great option for those customers that are coming from other general purpose Linux distros. Or in some cases, you're just running lift and shift applications that need to mutate the host, that need to mutate the file system. You're installing binaries from different resources, or we've had customers who have internal package repos. So even though these aren't best practices for Kubernetes environments, it's a great option. OS Guard is a security optimized flavor of Azure Linux that we've released really for those customers that want to start with cloud native best practices from the get-go. So it's great for applications like Sarah's, where she was building a new platform from scratch. It contains, as I mentioned, 100 fewer packages, and one notable difference between the two is that OS Guard uses SELinux for mandatory access control, and on Azure Linux base image, you can use AppArmor. So I want to get into the technical details of some of the capabilities we offer. So one of the things we use is dm-verity for integrity enforcement. The way dm-verity works is the entire /user is broken down into 4K blocks and hashed. Those hashes are combined again into 4K blocks and hashed until you get a root hash that is signed. Anytime there's access checks or boot, you're just checking that particular root hash and then the layer 0 hash that you're accessing. This ensures that enabling dm-verity doesn't adversely impact performance of your application, whether that's at boot time or during reads of any applications. For secure boot, OS Guard uses UKI, and this is the difference between regular secure boot and secure boot with UKI. The only thing I want to talk about here specifically is that you'll see that the kernel and the init ramfs are packaged into one unified kernel image and signed. In addition, we're using systemd boot instead of grub to actually do the boot process. And finally, integrity policy enforcement. So without any protection, this is what the security posture looks like. Unverified binaries can execute. Unverified binaries within containers can execute. Today in Linux, the industry state of art is to use SELinux or AppArmor to restrict access. So you have an unverified binary on the host, it won't be able to do anything based on what SELinux and AppArmor do. With OS Guard, we are introducing IPE, which is a kernel module that we've upstreamed into Linux. We use it in some of our most critical silicon platforms today. And this prevents binaries from even loading and executing on the node or inside the container image. The way this is achieved is we add a container image signature manifest to your container image package. The OCI artifact has the container image manifest, and there's a signature manifest. When this gets pulled, the signature manifest is checked against the key that the OS trusts, and if it doesn't trust it, the OS won't boot up, or rather the container image and the apps inside won't run. So the final section I want to touch on is some roadmap and resources. So what's coming down the line for Azure Linux? Some of our recent announcements that we just had, in addition to pod sandboxing and OS Guard, that I'm excited about is AKS Automatic. So for those who are attending the AKS Automatic session or have heard about it, it was in Scott's keynote, Azure Linux is the underlying operating system that powers AKS Automatic. It's something that customers of Automatic don't need to care about, but it is the option that we chose because we are offering best practices on the platform. Upcoming announcements, we want to enforce SELinux in enforcing mode on OS Guard. Have IPE in enforcing mode. This is likely going to be an opt-in feature because we don't want to change everyone's workflows for how container images are signed. IPE, while fantastic, does and can be a little bit disruptive in the sense that you need to sign your container images, so we want to make this opt-in. We want to further minimize the image by removing the shell and interpreters. So, the OS Guard image today, I was able to exec into it and run commands. That is something we want to just get rid of completely. And alongside that, removing any interpreters, so no Python on the node. Dongha talked about pod sandboxing. We want to introduce GPU support there. This will unlock capabilities that are in the AI space where you can run agents and sensitive code from those agents get sent to these sandboxes to run. And lastly, one that I'm really excited about is Azure Linux 4.0. So I know we just released Azure Linux 3.0 last year, but the team's already hard at work on 4.0, and we have an exciting set of announcements coming alongside 4.0 when we do announce it. I want to leave this slide up for a little bit for folks to take photos inside. The 3 resources here will take you to the Azure Linux documentation page. The second one is the Azure Linux GitHub. So everything we do is public on GitHub. You can leave issues, and we try and respond to them as quick as possible. There's people that open up PRs all the time. And we do have community calls. So these happen on a bi-monthly cadence, and usually we have customers or partners come talk about how they're using Azure Linux in their environments, or we announce with partners new integrations for how they integrate with the Linux OS. And here are the resources for our announcements. So our announcement blog for OS Guard, the quick start for OS Guard, and I'm hoping people don't need the TSG right away, but it's available if something goes wrong with OS Guard. The same thing for pod sandboxing. So we have pod sandboxing blog announcement, a set of quick starts. One thing I will encourage folks to do is actually go to the pod sandboxing lab. So if you want a curated lab that will walk you through end-to-end of how to get started with it, it is a fantastic resource. And here are the related sessions that we have at Ignite. I do want to plug the one I have coming up in just 45 minutes. I'm going to start with a .NET application, and then I'm going to build a containerized environment on AKS with the least CVEs possible. And so a couple of decisions I'll be making along the way is which container image do I start with, and I'll talk about the benefits of something called distroless containers, which Azure Linux offers. And then the second decision I'm going to need to make is which underlying OS am I going to pick for my AKS cluster. And again, I'll do a comparison and contrast of all the options. And in this case, I'll go with OS Guard. And then we'll see the overall CVE posture of the application. It's all going to be live. It's going to be 25 minutes. I am a little nervous about the live demo. But here are the other sessions that you can go to. We have 2 on Thursday. We have a lab that's been happening every single day, and we have another version of it this afternoon on 3:45 and Thursday at 9 a.m. I also do want to introduce Azure Accelerate, which is the new sort of landing place for Azure Migrate. So if you go to this link, you will get access to all the trusted experts. You have access to Azure credits to get started with your Azure journey. And we have scenarios that spans migrate, modernization, and covers how you can get started with AI scenarios. So it's a great place to get started on your Azure journey. Here is a link to the getting started for this session. So if you want to just land on the Linux and Azure docs, this is going to be the place to do that. And I want to end by opening it up for Q&A. So we have ample 10 minutes of time for any Q&A. And I think they're going to bring the mic up to the middle of the front. And please feel free to ask any questions. But thank you, everyone, for listening to our session on Azure Linux for AKS.